Can you hear me okay? Good? Excellent. So I'm from Dallas, Texas. That means that my Japanese is pretty much non-existent. Cowboy here. Gomenasai, sumimasen. This talk will be in English. Thank you for having me at RubyKaigi. This is pretty much a dream come true for me. You're going to get a little bit about my history. So my name is Amir. That's my Twitter handle. And I'm an indie game developer. I've been doing it, I guess, for now about 3 years, on and off. And I'm a storyteller. I built a minimalist text-based RPG called A Dark Room. Out of sheer dumb luck, this somehow went viral and made it to the #1 spot in the App Store. So it has about 2.5 million downloads to date, close to 25,000 5-star reviews, and it stayed at that #1 spot for 18 days. So quite an accomplishment and completely lucky from that perspective. So how do you do a follow-up to that kind of success? Well, I built a pre-sequel, and I made it very difficult. So for those that have played Dark Souls, you'll like the ensign. I imagine there are some smiles that came up, or tears of joy with regards to Dark Souls. So I made a game called The Ensign, and it was also well received. So I was pretty happy about that. So I took things to the next level, and I built a game about a bouncing circle. So this circle, it's actually a rhythm-based game inspired by Edwin Abbott's satirical novel, Flatland. So it's part of the Gutenberg project. It was written in the 1800s about the Versailles era, and kind of Edwin Abbott was actually a very learned mathematician. So it's about this two-dimensional world and the shapes that exist in the two-dimensional world, and kind of the society that they've built around themselves. So I'd like to play a trailer for the game. I actually partnered up with a composer. So he did the composition, because I can't do music. He did all the composition for the game, and I did all the gameplay and artwork. So here is the trailer. This is the two-dimensional world our wonderful circle lives in. And he bounces through this world, very happy. Unfortunately, he meets soldiers, assassins, very large squares, and has to avoid death at every turn. So there is your little trailer for A Noble Circle. And we'll see a bit of the gameplay as the presentation goes on. So, man, I love this stuff. These games are my heart and soul painted on a digital canvas of ones and zeros. Again, I really can't imagine doing anything else right now, or at least for the foreseeable future. And I'm very lucky that Ruby put me in a position to be able to build games for mobile environments. So just to give you a little bit of background of how I got here, I was actually a .NET developer. Don't kill me. And I did C# development for a good 7 years, till about 2010. So when 2010 came around, I was tasked to actually do build automation using Rake. So this is a really simple build task. It uses a gem called albacore. And it turns out that batch files are terrible to do build automation in. Same thing with XML. You never want to do any kind of build automation in XML. It's a bad idea. So we used albacore and Rake to do our build automation. A very unfortunate aspect of doing development on Windows was that you have to basically deploy your website to the default directory, which is inet www root, and you basically blow away that directory and then copy it over. So I actually never did Rails. It was always Ruby, and through build automation, that's kind of how I became a Ruby developer. So it took me a while to see the beauty that Ruby brought to the table, and it all started with this one single variable being the output path, which was the process working directory. So the most elegant thing that I saw was that I could create a function for this output path, And then I could delete this reference to the variable, but the call site didn't change because I didn't put any parentheses on my method calls. So that was something subtle, but not something that I experienced in C#. Eventually, I took this function and turned it into a module, a next evolutionary step, right? Local variable to a function, function to a module, and then I would include my module, and again, the call path didn't have to change. And this was when I really started to see the power of having this ability to evolve your code very slowly and defer the need to create something that you may not necessarily need at that point in time. In this case, in C#, it would have been a class. It would have started off as a class. There was no way I could just do a bare function or bare variable. So being able to do that with Ruby was something that was very enlightening to me. And then eventually, I took the approach of actually making it into a class. You can see the diff that comes up there. Instead of include, build, deploy, we have our instance of our build, and deploy class. I have some state that I managed, and then I turned that into a class. And I have my final construction for this rake script. And this was a turning point for how I thought as a developer. And I actually spent a lot of time in the .NET community trying to influence this kind of change, trying to get my fellow members to see not necessarily just the aspects of dynamic typing, but this evolutionary aspect of building software. Is something that I think I definitely relate to with regards to Ruby. So I actually created a dynamic library in C#. So C# has something called the dynamic language runtime. And here I created a dynamic class called Gemini. And if your call site or if your function definition returns dynamic and takes in dynamic, I can implicitly treat this as a public function that can be redefined. You can initialize an instance of this class by actually creating a person type, or you can pass it an arbitrary name parameter like in a hash. So this was a little ugly, but it worked. I took it a step further and actually got modules and method missing working in C# in a statically typed language. Again, I'm crazy, but I got it working. This should probably have been called include instead of extend, but basically I could take any instance of person and redefine all instances of person to return something casually as opposed to the original definition. Again, based off this idea of this dynamic language runtime. Method missing, you would just define a method called method missing. You'd get the call info. Here I create, this is basically defined method, I call it set member. And I'm able to create an instance of all attributes, if they end in HTML, to URL encode that property. So just a very trivial example, and then I throw member doesn't exist exception for doing that. So 2010 is when I started getting into Ruby, started learning Rake. I spent 3 years of my life trying to influence this philosophy of incremental design and this evolutionary design in a community that generally wasn't receptive to it. And I learned a lot during the process, specifically around how to create dynamic runtimes and how to bend a language to your will. Specifically with C#, one of the interesting things that you got was this, you could actually have, what's the term, progressive typing. So you can start with the dynamic type, and then using something called an explicit cast operator, actually create a static type from that dynamic type. So you had the whole spectrum to work with, which was really powerful, but again, not something that the community as a whole was receptive to, unfortunately. So I gave up. I gave up so bad that I actually quit my job, and I sold everything I owned, pretty much. So I talked with my wife and said I need to take some time off and just kind of do my own thing. We went from a 2-bedroom apartment to a 1-bedroom apartment. That picture there is everything that I owned. I got rid of my PS2, my PS3, my GameCube, my PC, which had a 30-inch monitor and a 27-inch vertical monitor. I remember every game, Beautiful Joe, Smash Brothers. It was very difficult for me to do that. My wife kept all of her stuff, and I had a car and clothes, and we had general furniture. But as far as what I consider my worldly possessions, that was it. And it fit into the same backpack that I have now. It's the very same backpack in that picture. And I took this time to do what I wanted to do. And what I wanted to do was build games. And that's what I did, by golly. And before I start getting into the actual games that I built and kind of the lessons I learned from building these games, I'd like to show you kind of how I perceive development to be like. And I kind of see it as drawing. So this was a drawing that I created. I don't think I'm very good. There's two parts to this. After you watch part one and I haven't been booed off the stage and maybe I hear some clapping, I'll play part two and then we'll continue this. But I think this is a corollary that you'll actually feel with regards to development too, is that you don't start with very dark lines and very concrete structures. Those things evolve over time as you learn the shape and form of what you're building. And this is the best way I could demonstrate how I see development in programming. So you see errors that I make erasing, and then some hard lines to get the structure of what I'm trying to build out. And of course, you have to have a really big, badass sword. So this thing has a badass sword that I do. And you gotta have the cool, awesome hair that I can never have with the antennas. But, and then the awesome cape that comes in at the end, right? You gotta have an awesome cape. And then there's your sword. But this is kind of how I approach development. And then once you get that structure, you fade that away to really start working in the details of what you want to build out. And that's when you start solidifying what you want to develop. So those initial stages was like the variables that I was creating. And now I'm into the point where I'm actually creating modules and classes to actually really go in and try to encapsulate and capture what I'm trying to draw. And this is mentally what I go through when I build software. So that was part one. Do you want to see part two? Yeah, there you go. All right. So part two is a little bit of the same thing. We're going to actually, it is just primarily for curiosity. You'll start seeing details that I put in the hands, and then eventually you'll see how I do shading. Shading, again, is very similar to how I did the initial sketch, where it's really rough at the beginning, trying to get the overall structure, and then eventually you'll see some of the polish that I add to this stuff. So it's right here, it's very subtle. Surprisingly, I did this all on an iPad Pro with a pencil. So I love doing it this way, especially this also helped me build video games. A lot of the sprites and stuff that I create are actually done through just doing it on a digital medium and then sharing that over. So here's the shading that I was doing. And you'll notice that the shading itself is generally really rough. And I just kind of cut those pieces in, and then I come in back and I really start polishing and adding highlights and stuff. So again, this is how I see development and how I see what Ruby has showed me about how code can evolve. So the first thing I did, of course, is, and it was not a mistake, but the first thing I did was I built a game in JavaScript. It's like, all this talk about Ruby and you're doing games in JavaScript. Are you insane? So let me show you the game. It's called NodeKick. I actually did this as part of a hackathon with a couple of friends. And let's take a look at this super awesome game that I built. Has anyone played Divekick? If you've played Divekick, you'll actually like NodeKick. So I press up to spawn my player. And I use jump to jump. And right and left will attack.
Headshots. Killing streak. Headshots.
RubyKaigi right here.
Idiot.
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 So I actually did the sound. That's actually my voice doing all those things. And I used a program called Audacity. And I added reverb and echo to create the very Quake style headshot.
Headshots. Bird of prey.
So So that was lots of fun, being able to build that kind of game. You can actually play it here. I've deployed this to a Heroku instance, and the source code's available too for you to actually run yourself and actually get working. So one beautiful aspect about JavaScript, and one thing that I loved about Node.js, was the same idea of incremental development. I can start with one function and then evolve from there. And I also got a good understanding of just first-class functions. That's something that, you have procs and lambdas and some different variations of functions in Ruby. But being able to just have a bare function was really nice to be able to do. So for those that haven't done game development, your general game is a tick. You have a tick, and it executes every certain frame rate. So in this case, it executes every 60 frames. So 60 times a second, this tick function would execute. And during a tick function, you take control input, you do your compute, and then you render the screen. So for control input, basically, I'm looking at live players. I iterate through, I apply gravity. Gravity is up there. So if you're jumping, there's a delta of gravity that keeps you from flying off the screen. And if you're kicking, then another velocity is applied to your direction. And then after that, I kill you and determine whether you hit someone in the head or the body, and then do a sound. But this is the tick, and this was something that I loved about JavaScript. And the Node.js environment was that I could start with something very simple: one file, one function, one variable, and then iterate on that. Unfortunately, with JavaScript, as you all do know, you end up getting something that looks like this. Did you get the pun? This? No? No? Like I have him flipping a this. Come on, guys. But you get something that looks as ridiculous as this stuff. So this is the player class, and when you start forcing these functions into classes, you get this crap, and that was not fun to do. So usually, multiple times I've talked with people during this conference, and I go, oh, what have you been doing? I've been doing React on the front end, JavaScript, right? And this is why. This is the frustrating part with JavaScript. So JavaScript had that incremental aspect at the beginning, but it kind of fell short for more complex structures like what you see here. And that's what I generally felt when doing JavaScript. But it did do a good job of capturing that initial starting point. So I binge coded on that. After that, I found a game called A Dark Room. It's a web-based game built by Michael Townsend. And I ported this game to iOS, and this was the game that effectively changed my life. So this game was built in RubyMotion. Laurent Sanzanetti, he's my hero. Also Watson and Mark. Those guys are all my heroes in a phenomenal community that I'm lucky to be a part of. But I built an iOS version of this game in RubyMotion, and now it's also on Android. And this was something that, if Ruby didn't exist, I would not be standing here today speaking about how I built a game with RubyMotion and Ruby itself, because I'd probably still be trying to write the damn thing in Objective-C. So just to give you an example, so this is a battle sequence that you would find inside of the game. Old school. Attack. So we'll watch it one more time because it's awesome. So you embark, you have your map, attack. There's the battle sequence. Old school Japanese JRPG style. And then you got loot at the end, which is so cool. Oh wait, that was the other game, sorry. Are they still fighting? My bots are still fighting over there. That's so cool. Yeah, I have bots in this game. Crazy little bots.
Lamb to the slaughter.
Okay, sorry. Man, you guys are mean. So here's the battle definition there. So I have because of class methods, I'm able to define methods on the instance, and it's elegant. It's nice. You can see the actual title, the text that shows up, the DPS for that specific entry, and then the loot that you get. So this little thing gets anywhere from 3 to 7 fur, and then there's a 100% chance of you getting that loot. And the class itself is very simple. elegant, which I would expect nothing less from Ruby. So being able to define a battle sequence this way is much better than what you would have to do in Objective-C, which is this. So this is Objective-C. If you haven't gouged your eyes out yet, the plus sign means class variable. It doesn't mean public, it means class, or class method. The minus sign means instance method. There are no, you have to use the @ operator for your dictionary hash values. You have to precede all strings with the @ operator. So this is a dictionary. Dictionaries cannot hold value types. So you have to box everything, all your value types into reference types. And I usually call this the bloody stump operator because by the time you've typed this thing enough times, your fingers are bloody stumps from pressing Shift 2 over and over and over again. And then for the dictionary value, when you return the hash, you have to, again, unbox the value. Or you have to box the value into the hash. So the base class implementation looks like this. Kill me, right? So here's the encounter event. You set the title, and then to unbox the value, you have to get attributes value for key, cast it as an NS number, and then num integer value to actually get the health value back out. So being able to type this as opposed to that is why I was able to finish the game and actually put it in the App Store. And this just goes back to the expressivity of Ruby. The great thing about Objective-C, though, and again, this is just seeing other languages, that Objective-C has a really great concept of message passing. So Ruby was compatible with that world. And that was nice to see. So we've talked about kind of how I approach development and how I see development. Now let's talk about some of the lessons I learned from doing game development for so long. One of the first lessons I learned was that there's a thing called non-determinable polynomial time and random number generators. So this is that same screen, and at the beginning you're going to see us traversing a ASCII-based map. You'll see it right here. So this is the ASCII-based map that you traverse. And then you go into an area and fight a battle. Well, because of how the map is generated, first it's random. All the landmarks are random. And on top of that, the strategy involved with traversing this map is NP. It's an NP problem. Zelda is like NP star, NP complete, so there's like a lot of problems. Surprisingly that we find interesting and find interesting for games are all primarily around NP problems. We don't like playing games that computers can solve in a reasonable amount of time. So when it came to my testing practices that I built up building CRUD-based applications or general web applications, they did not apply to this kind of world. And I couldn't test this outside of just manually playing it and have other people manually playing the game. Same thing with the random number generation. That adds another layer of frustration. You can stub it out kind of, but it's really hard to capture the impact that you can have by removing the random number generation like so. So when you're building games, your testing strategies end up just being different and at points impossible. And that's what I found out with regards to building these kind of games. So that was a lesson learned, unfortunately. For Noble Circle, I got really good at math. I got really good at trigonometry, geometry, and that kind of stuff, as much as exciting as that sound. After I did a lot of the math, I had nightmares that I didn't graduate high school. And that was, tell me you guys have that, right? You forget you're taking a class or some variation of that. This definitely peaked during this time period. So here's simple collision detection. Basically what you're doing here is you have a circle and you have the shape that you're trying to collide with. So I actually cheated for quite a bit, for a good few months, trying to get this collision detector working. And basically everything in this game spins at some point. And so I can create a box around that spinning thing, and then doing collision detection is really easy. Basically, you're always testing the boundaries and making sure that they don't intersect. And by doing that, you get really simple collision detection. So here it is in action. Ow. So there's the collision detection in action. This is using, again, RubyMotion. I'm using SpriteKit for this variation. So that was cool, being able to do that. But then I had to deal with complex collision detection. And the idea behind it, let me show you the complex collision detection that you're going to see here. I'm going to go and full screen this. And do you see that it's kind of light, but there's like this blue box around this thing? I'm showing the border so you can kind of see what this looks like. And this is another part of the game where you have to pass lasers. Lasers. And there they are right there. Holy crap! Who made this crazy game? So there you go. There's your lasers that you had to do. So complex collision detection was complex. Terrible joke? No? Okay. And what you have to do there is you're no longer looking at a square. You're looking at an arbitrary convex polygon and a point. So for this rectangle, basically what you have to do is to determine if a point is inside of a square, you have to create 4 triangles right there, right? You see the 4 triangles that you create from the points. And you take the areas of those triangles, and if the area of those triangles is less than or equal to the area of the square, then the point is inside of the square. If it's greater than, then the point is outside of the square. So the tricky part with doing area of a triangle is that a triangle is half of a square, so it's base time height divided by 2. But the problem is that that only applies to right triangles. So for scaling in obtuse triangles, you have to actually find the right triangle in this shape, and then do the base times height and figure out whether it's obtuse, an acute triangle, equilateral, or right triangle to figure that out. So first you have to find the triangles, then you have to find the right triangles within those triangles, get those areas, compute them all together, find the base and height for those specific right triangles, and then you get the area. That was completely complicated. So I found this thing called Heron's method, and his name it's also called the Hero formula. And it was Hero of Alexandria that actually created this, and it gives you the area of a triangle, but requiring no arbitrary choice of side as base or vertex as origin. So that was cool. And then I looked at the method, and I was like, flipping tables again, because that is complex right there. And what was frustrating, specifically with game development and this idea that I had with evolutionary software, was that there was no evidence that the engines that existed out there took that evolutionary approach. So the logic for doing collision detection was baked into the actual node and physics bodies that existed on the sprites. It was not just a function that I could call independent of the sprite itself. And that was really frustrating. So I had to do it because I'm stupid, and I didn't have enough time to actually figure out the geometry of all that. So basically, you have to define a physics world, and then you have a category bit mask that's applied to a 2-byte value, right? So for my circle, it's set to the circle bit mask, and it responds to the enemy bit mask. And for my enemies, it has the enemy bit mask and responds to the circle bit mask. And when they contact, you get a callback or an event that gets raised, which again is really frustrating because you have this game loop and this tick that goes through the compute cycle and the render, but then you have this arbitrary event that comes in that has to be handled for. So it was inconsistent with how I thought about game development up until this point, but I conceded and just had to do it this way. So I guess this exists in all frameworks, right? A lesson learned here is that it exists in all frameworks. It exists in all software. It's something that you have to deal with and concede to at times, even though you don't want to. So that was just an unfortunate bad point in that. So my next game was Spirit of Akina. Drift to physics. So this game I built around December 2015. I haven't released it to the App Store yet, but it was lots of fun. We're going to see me drift around corners. Does anyone know what that car is? Hachiroku. Hachiroku. I'm on Gunma. Gunma Mountain. Driftu. Y'all have watched Initial D, right? Come on, I'm not. No? Please, go watch Initial D if you haven't seen it. Driftu. I don't have collision detection working. That's why you can just kind of fly off. It's fine. It's okay. The controls on the left are your left and right, and then that big circle right there is your e-brake. Driftu. I just love saying that. Oh gosh. So this is the 5 consecutive hairpins that are iconic to the anime itself. There we go. All right. So so this was again lots of fun to build, and what I found out. There's actually a paper on this called Car Physics for Games. It's literally called that. I was like, I need to figure out how to do car physics for game. I Google it, and it's like, here's this paper. This took me 2 weeks to kind of figure out exactly how to deal with car physics. So it's really interesting. Apparently, cars don't have a top speed. It's actually the drag coefficient that makes you reach terminal velocity. So if you're actually in a vacuum and you drive your vehicle in a vacuum, you could accelerate and forever up until you run out of gas, because you'll probably run out of gas before you hit the speed of light, and make everything turn into a black hole and explode. So you don't want to do that. But basically what happens is that you have your engine power, that increases your speed, and then the drag coefficient and the air resistance is what keeps you from going faster. So that's why there's so much effort put into wind tunnels and aerodynamics for your vehicle, because decreasing the drag actually increases your speed. Imagine that. So my initial attempt at this game, I actually had a top speed that I would cut the car off at. And then after spending 2 weeks of reading all the physics involved with doing car and weight transfer and wheel ratios and all this stuff. This is a great read. You've got your gear ratios and how they affect torque and power output, and then the friction of your tires, the slip ratio, all this stuff is just really, really fascinating. And I actually got it working. It was really, hey, how's it going? I'm gonna let them fight again. They're happy. I mean, you gotta keep them happy. Like, hold on. Boom.
Headshots.
Gotcha. So it was very cool to work through that. And there's something interesting that I learned from this aspect, was that I spent all that time getting the physics perfect for this vehicle. And you can actually see the turning physics work out really well in this, right? So this is the actual turning that you see in the vehicle. But when you hit the e-brake, I break reality. So here's that first awesome drift that I did. And what I found out was that being to the T with regards to physics isn't very fun. You have to kind of break your reality at times. And for me, the way I broke the reality was when you press that magic button right here, I basically make the exit full screen. Okay, I make the tires kick out. I actually increase the rear acceleration of your tires by like tenfold, and I decrease the slip, and I make it feel like you're on ice. But your front tires actually still simulate. They work as if you're still on a regular road, and that's how I was able to get the kick out. And that was just something that I had to do to get this world to work correctly inside of my super awesome Initial D game. And so that was interesting learning. Again, the math was elegant. It was beautiful to actually go through the math, to see that evolve in Ruby, and then find someone got killed. Whoa! And then finally see that actually come to fruition, and then having to break reality. And it was nice. It was enlightening to be able to do that. So I made one more game. It's called Beautiful Go. This was based off, of course, it was another anime, inspired by another anime called Hikaru no Go. And I myself wanted to learn how to play the game of Go because of this anime. So of course, instead of learning to play the game of Go by buying a Go board, I decided to build an app, as all good developers should do. And this was the initial version of the app that I created. And this was my attempt to bring Go to a digital medium. A lot of the Go apps that you see out there right now, Baduk, Ego, Go, apps that you see out there have the wood grain boards, and they have like all the crosshairs for the sections and whatnot. And I wanted something that portrayed the Go board, but in a digital medium. So for those that don't know how to play Go, basically you alternate white and black. I picked other colors because I wanted to be fancy. And if you surround, that one doesn't need to be surrounded. So if you surround an opposing player, it's called taking away all their liberties. These openings right here are your liberties. You're able to pick up the piece, and that counts as a point for yourself. So the evolution of Go, or the beauty of the game is that it's almost, instead of it being a tactical game, it's more strategic and long-term, where you try to create these regions for your Go board, and try to build out dominance on the board by having almost a compromise and a give and take with your opponent. So being able to visualize that in a digital medium was something that I wanted to really do. But unfortunately, as a lesson I learned was that you still have customers for even video games. You can't just pretend that you're building your video games for yourself, build games that you love to build, but there is still a customer aspect to it. And it was generally rejected as a Go game. They saw it as Connect 4. I was like, this is a stupid Go game. I can't believe you built this. And I asked them why they wanted these crosshairs that existed. And they said it was because it makes it easier to count liberties. It turns out that this beautiful Go board made it difficult to count the liberties that existed around a given unit or a given piece, which is why I took this approach. And this was the final version of the game. So there's your liberty right there. This is a 5x5 board. And I added some pretty sounds. And I actually count out the liberties that are open. So when you place a stone, it shows you all the stones that are impacted by that placement, and it shows you how many open liberties that you have. Connected pieces have to be, I hate when they do that. Connected spaces, that means to surround this, you have to actually put, a black piece here, 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 and here to surround that. But this was that was a good compromise that I created inside of my Go game, being that I tried to, corollary to general software development, you try to understand your customer, you try to understand why they want something so badly, and in those things it was to count liberty. So not only did I add the crosses back, because that was something that they were used to, but I also, on the pieces themselves, added the calculation for them, so it became a little bit easier to see what was open and what was closed. And that version was really well received. So that was kind of a summary of the last 3 years of games that I've explored and built, and there were many failures along the way, as with all software. But most of those games saw the light of day, and some of them are open source for you to play around with and watch bots kill each other for eternity. The challenge here is the current state of game dev, I think, is hit a local maximum. We have 3 pillars that I generally see, and that's production value for your game mechanics, and then your narrative. And those 3 things come together to create gameplay. And I think we've hit a local maximum with regards to graphics. Production value, you have AAA games that have phenomenal graphics, both on mobile and PC and console. And we've done a really good job of capturing game mechanic and seeing games do really well there. But with regards to narrative, I think we've lost that aspect of the craft. And it's something that I kind of have to compensate with regards to doing narrative, because I'm not very good at the artistic aspect of it yet. But another challenging aspect is that history is repeating itself, because what I've experienced with doing game development with incremental and this evolutionary approach in Ruby and JavaScript and Clojure, it doesn't translate well to C# Unity, C++, and Cocos 2DX. So there's a light of hope, of course. For me, it's Ruby Motion. There's an open source project called Motion Game that I'm contributing to. It's actually C binding to Cocos. It's a Ruby Motion, Ruby C binding to Cocos 2DX that you can use to build mobile games. There's a wonderful presentation by Zach Oakes. It's about game development and closure. And then Brett Victor, he talks, I'm sure some of you have seen this, but he talks about doing game development and like feedback loops and how different languages can help you visualize and experiment with the things that you're building. So my first slide was game development plus Ruby equals happiness with the question mark. As of right now, it's a yes, so I've got my happy face. And I still feel that way, and it's just a matter of deciding how much I want to influence the community outside of just sitting by myself and continuing to build games. But I hope you enjoyed the presentation again. This was an important moment for me personally, going from doing .NET and then finding myself in a community that I feel more comfortable in. And in one of the best, most awesomest places, Japan, and in one of the most prestigious floors being RubyKaigi. So thank you for your time. Thank you for listening.